Hello everyone, and welcome to the SQL Plus overview for version 4. I'm Alan Heineman, and today we're going to explore how SQL developers can make use of their existing knowledge to build enterprise-grade data services. That's right, I said SQL developers. If you are serious about data and you've invested your time to be proficient with SQL, SQL Plus will allow you to leverage those skills to make building data services effortless. So let's explore the two key components that make this possible. SQL Plus semantic tags, which I like to think of as a natural evolution of the SQL language, where any shortcomings of SQL in the context of building services are compensated for by adding these tags to your SQL. Things like validating the length or format of parameters, providing comments for clarity, enumerating return values, and more. These semantic tags can be applied to stored procedures, scalar functions, table functions, or SQL command text. We chose this approach because it promotes dry principles. By applying these tags in your SQL, you have the ability to define a comprehensive contract in a single location and have that contract enforced across the entire enterprise. That makes your SQL a single point of maintenance and SQL Plus services the gatekeepers of pristine data. Once you've added these tags to your SQL, you use the second component of SQL Plus, the code generation utility. This Visual Studio extension reads your semantically tagged SQL and uses that information to generate an object-oriented class library. To run the utility, simply launch the builder, connect to your target database, select the database routines and queries that you want to include in your build. Optionally, choose any build options to fit a given use case, and that's it. Run the builder, and you now have an object-oriented class library with built-in validation and unrivaled performance. So let's have a look at how our new data services work. If your SQL has any input or bidirectional parameters, they will be encapsulated as properties of an input object, with your semantic tags controlling the validation, providing comments, and enhancing display properties. Each input object has an isValid method to test validation against the tags applied to those parameters. You execute a service by passing a valid input object as an argument to the service. The service executes and returns an output object. That output object will encapsulate any output or bidirectional parameters, enumerated return values, and any result sets that the service produces. We chose this object model for a few reasons. It subscribes to solid principles, but more importantly, in the modern world of building software, we need our services to be as flexible and portable as possible, since we don't always know how other developers are going to interact with these services. They may want to use them with web forms, Razor pages, expose them as REST services through Web API or Azure Functions. They may want to redistribute database events after successful CRUD operations, add caching, or even implement a CQRS pattern. Having your data services represented in this object-oriented way facilitates all of those scenarios. As an example, here is a stored procedure that handles a customer save, or upsert if you will, and it's fairly obvious what's going on here. We have a routine tag that defines our service and provides some meta information about it. We have tags applied to the parameters for validation, comments, and display properties. If this routine is called with a customer ID of 0, it follows the insert path. Otherwise, it follows the update path. Then we have return tags that provide an enumeration back to the developer using your service that allows them to determine the outcome of the call. They can then use that information to dictate program flow. So let's see how SQL Plus services work in the real world. Here's a Razor Pages form that uses data binding to wire up to our new customer save service. Notice how the user is forced to comply to the validation provided by the semantic tags. The exact same pattern works in a Blazor WebAssembly application, although in this case we hit an HTTP endpoint that in turn calls our service. And if we hit that endpoint directly from Postman, we can see how having the isValid method on our input object allows us to reject an invalid request and return a meaningful response. And in all these cases, the functionality is provided by the use of SQL Plus semantic tags. And that's a pretty cool way to build software. This is Alan Heineman from SQL Plus. Thanks for stopping by and have a great day.